Hi, my name is Casey Walters, and I am one of Miss Benzie's scholars in her quantitative literacy class. And today I'm going to be going over our Module 3 Excel report. And I'm going to go ahead and share my screen with you now. Okay, and before we get started, like I said, we're in Module 3, and this is my Excel report. And this chapter is over statistically speaking. So we're going to be going over statistics. And I do want to go ahead and share with you that I have found, it only took me a few weeks or half the semester to figure out that if you actually do your Excel report first, then when you do your homework, you will actually already have your homework done. So just FYI. Anyway, what I'm going to start with is I'm going to go ahead and I'm going to go up here to formulas. And if you will look at my Excel report right now, you'll see it a certain way. And then I'm going to go over here, like I said, to formulas. And, oh, hang on. And I'm going to show formulas. Okay, and so what I'm doing is basically showing you that I didn't just go in and put my information in here, build charts and everything else just based on the data. I actually used Excel to build this and to make this class a lot easier. So you'll see all of my formulas in here in each place, as they should be. And then I've gone one step further, and you'll see down here at the bottom, I actually have my path. And you can go in here to my path, into anyone's path, and if you haven't taken BCIS, you will learn that is a mandatory thing in order to get your grade. Okay, so let's go ahead and turn those formulas back off, get it the way it's supposed to be, and let's get started. Okay, so what we have done here is, number one is Americans' attitude of climate changes between the years 2010 and 2015. I have a chart right here and a chart right here. And what we did was we were asked to, and this was homework number 10 question, American attitudes towards climate change have been evolving very rapidly over the last few years. The tables below, right here, show responses to the survey question from what you've read and heard. Is there solid evidence that the temperature on Earth has been getting warmer over the past 4 decades? First in spring of 2010, then again in fall of 2015. Construct a pie chart for each set of data. And show data percentage equivalencies to 360 degrees. That's 360 degrees. Label chart according to the story, as I have. Which basically I made these charts, and then I used my handy dandy tools to create a chart or a pie graph with the data in the tables. And so you'll see these have been done right here. Construct a bar chart for each set of data, label chart according to the story. And that's what I've done right here, and I was able to do that as well with the same tables right here. And I was able to determine from the data that from the years between 2010 and 2015, Americans' responses to the climate getting warmer has changed. It was a 53% change in 2010 from those who believe it is getting warmer. And that number increased to 71% in 2015, which is drastic. That is up to 18% in 5 years' time. The number of people who believe that the climate is not getting warmer has substantially declined, also from 37% in 2010 to 17% in 2015. The number of those who are unsure has seemed to rise over the 5-year span, 1% in 2010 up to 12% in 2015 in the rise. One reason I believe that the number of people who believe that the climate is getting warmer is that we are much more conscious about global warming, which of course that isn't even the social acceptable way of saying that at this time. But you know, that changes all the time. than we were in the past. Next, in order to create a pie chart, you need to have a 360-degree circle. And on my 2010 pie chart, which is right here, the number of those who said yes would be 190.8 degrees, which is right here. And those who said no would be 133.2 degrees of that circle. And the ones who are unsure make up 3.6 degrees of the whole circle, finally, on my 2015 pie chart, which is right here. Okay, and then comparing data sets of missed class sessions and height differences. Like I said, if you haven't taken this class yet, or if you aren't finished, be sure and do this Excel chart before you do your homework in MathLab, because these are your questions. Okay, so these are homework questions 22 through 23 and 26 through 27 in MathLab. So the table below, this one, or yeah, shows the class periods missed over the 10 classes or 10 courses by 2 students. The 2 students were Helena and Juanita. The height in inches of 9 Army recruits, list 1, and 9 randomly selected people walking through a mall, list 2. That's this one and this one. List 2 are shown below. And so that's these. Okay. And we were asked to calculate the range, median, and mean, and standard deviation, and coefficient of variation for each set of data. And that's where this is right here. And if you don't remember how I said to go back up to formulas and then go over to show formulas, you can always press on each thing and it'll show the formula right here. And we were also asked to create a scatter plot, which that's what these are, and insert a trend line for each scatter plot. Notice the correlation between the tightness of the data and then lines relative to the coefficients of variation and the standard deviations for, you will include this observation in your report. So here are the plot lines. Create a box and whiskers plot for each list of heights. After you create a box and whiskers, reorder your list of heights and highlight Q1, the median, and Q3, the minimum and maximum values for each list of heights. Notice the correlation between the box and whisker plot ranges and your highlighted values for the quartiles of the heights. Also notice the correlation between the ranges, standard deviation, and the coefficient of variations. You will include these observations in your report, which I have. And you will see those here. And basically what I found was, by looking at these sets of data in Helena's missed classes, the data seems to somewhat follow along the trend line. There looks to be this be some sort of order. That's what I was explaining, order. This is the order, this is the trend line, and it's kind of like there's a balance per se. Whereas with Juanita's, there's not. And Helena's missed classes, the range was 2, median is 3, and the mean is 2.5. The standard deviation for this data set is 0.7881, and the coefficient variation is 0.281718. We can see that the standard deviation and coefficient variation are smaller in this data set. However, in Juanita's data set, her data points are all over the place, and they are far away from the trend line. And that's what I was saying earlier. Trend line is right here, and she is all over the place. There's no rhyme or reason to her missed classes. So the range of Juanita's data set is 9, median 1.5, mean 3, standard deviation 3.52, and the coefficient variation is 1.17589. When analyzing the 2 sets of data compared to the other 2 sets of data, I can see that Helena's data is similar to the heights for mall goers' data in the sense that they both have very similar coefficient variations. Next, we were asked to make box and whisker charts for the heights of Army recruits and heights of those selected in the mall. I can tell from looking at the box and whisker plot for the Army recruits, the standard deviation is much smaller than that of the heights of them all. So that is right here, and it is much smaller, as you can see. Number 3, IQ scores of 20 psychology students conducting an experiment. It's pretty interesting for me. I am a social science major, so I found these sets of questions and homework number 29 and 24 through 28 to be rather interesting. They definitely drew my attention. So we were given some sets of sets of numbers, and we were asked to calculate the range, median, mean, and standard deviation and coefficient of variations for the sets of data. And here were the sets, and then here were the asked for things, the range, median, mean, standard deviation, and coefficient variation. And then here were the other things asked for. And then we were also asked to provide a bell-shaped curve to represent the distribution of the data, which once I had these tables made, it was very easy to do. All I had to do was select the table and then go up here or right click it and then chart it. So that's what I did, and it's a lot easier to see the information charted out in different ways. So what we found from this, the data set for the 20 psychology student IQs scores were asked to find the range, median, and everything. Like I said, I found these were the answers as follows for each. Range 43, median 103.5, the mean to be 105.7, and standard deviation 12.9822, and coefficient variation is 0.122821. I learned that if I added any outliers to my data set, it changes the shape of my bell curve and the box on my box and whiskers plot. I plugged in an outlier to the lower end of my data set, and I observed changing the original number of 129 to 225, that my bell-shaped curve changed and got a lot wider and bigger across. My curve also skewed to the left with that outlier. On my box and whiskers plot, the box shape changed and seemed to appear smaller. My mean changed to 110.5, standard deviation changed to 29.4074, and coefficient variation was 0.266129. They were all larger numbers than the original ones, with the standard deviation being the most notable difference, obviously. Next, I can see the percentiles starting at the smallest number is the lowest percentile that you can be, and the highest percentile is the 95th for the high score. The rank seems to be opposite. In the higher rank, you are the lower your score is, and vice versa. Last, the changes to the graph when outliers are added to the upper end was it skewed to the right, and when adding an outlier to the lower end, it skews left. It's pretty interesting. It's kind of like accounting. It's the exact opposite of what you would expect. So, moving right along, we are on number 4, data sets for larger dams in U.S. and South America. So I've always thought dams were pretty interesting and how they do that, and the Army Corps, how they do all that. Anyway, okay, so basically the same thing. We're still in statistics, so we were asked to write a report to describe the measures of data, discuss the effect of outliers on the mean and the shape of the box and whiskers plot, and discuss the difference between percentile rank and rank, and discuss the correlations between the changes in the calculations just the same. In the following data, represent the volume in cubic yards of the largest dams in the United States. So what I did was I made my tables right here. United States, South America, United States, South America, and then I have my X and my Y, so that, as we all know, that's how you chart something. You've got your X and your Y, and that's where it meets. So after I plotted all that out, I made my table, and then I made my charts. And here is my data right here. And I found that the two sets of data we were looking at dam capacities between dams in the United States and those of South America. I found the range for the United States dams is 75,628. The median is 71,100. The mean is 75,640. Standard deviation is 24,551.1306. And the coefficient of variation is 0.32458. In South America, the range is 255,297. The median is 103,979, and the mean is 151,055. Standard deviation is 112,459.1, and the coefficient of variation is 0.7449. Some reasons I think of which could cause differences in the dam capacities, or maybe because in South America, they had less amount of dams than the United States did, but while they have less dams, their capacity is much higher than the ones in the United States. The next thing I thought of is the capacity depends on what type of dam it is. There are different types of dams, and we are not given that specific information in the data specifically given to us, and the size of the dams could affect the capacity greatly too. So there we have that one. And then number 5, we are back to Z-scores, percentile rankings, and ranking calculations. So back to IQ scores. So being in college, this should come in handy, or this will in fact come in handy to you. And if not to you directly, then someone else is doing it for you. So an IQ test has a mean of 100 and a standard deviation of 15. Create a standard bell-shaped curve and label each standard deviation. Calculate the Z-scores, percentile ranks, and the number of students for each possible score within 4 standard deviations of the mean. Suppose there are 1,000 IQ scores reported in this data set, and suppose the required score is 70%. Discuss the number of students out of 1,000 who reach the required score. Discuss the 20th percentile, 80th percentile, write a report which includes information parts of A and B, and so forth. So that is exactly what I've done right here. I have used the information that was provided and made a chart. It's right here, the mean and the standard deviation. And then I have plotted each thing based on the changes and the data in the questions. And then I calculated everything right here. Like I said, this is my formulas. All you do is hover over to push over, and it's right here. And then I made my bell-shaped curve based on that. And then the standard deviation is these parts in between. That's why I put this right here. Okay, so in this problem, we were asked to create a bell-shaped curve and to label each standard deviation. And from there, we calculated Z-scores, percentile ranks, and number of students for each possible score within 4 standard deviations of the mean. The percent of the students who scored at least 70% was 97.6%. So that means almost the entire population scored the required score of 70% or better. The actual number of students out of 1,000 test takers who scored at least 70% were 976 students. I found that the number of scores in the 20th percentile was 25 to 21%, and those who scored in the 80th percentile were 24 or 20%. Then those who scored between the 20th and 80th percentiles were 72 or 59%. If we know how a certain amount of test takers scored on a test, this can help us to project and predict scores for larger populations. So this is definitely something for research and to collect data and kind of get an idea of how things could be and change and everything else. So finally, we are on number 6. And number 6 is in homework, it's going to be number 36 and 36 through 40. And it's setting reaction time in adult subjects that are alcohol impaired to study the effects of impairment on driving. The amount of time in seconds that 25 randomly selected adults took to react to stimulus when they had a blood alcohol level of 0.08 and was recorded in it, and the table is displayed below. So right here, I don't really like how that is, so I'm going to change it to black so that you can actually see it. Okay. All right. And so I've got a range, median, mean, standard deviation, and coefficient variations. And right here, I've got the tables with the data. And right here, I have our histograms, which is the reaction time for adults with a blood alcohol level of 0.8 and reaction time for adults with a blood alcohol level of 0.8. And that's my histograms. And this is with the different standard, this is with the deviations different. And then the reaction time for adults with the blood alcohol level of 0.8. And then here's our deviations right here. And in this problem, we were asked to create several different histograms, which I've already basically said for you. And according to the different scenarios, the first histogram I created in this real representation of the data provided, there's a range of 2.3 and a median of 2.4, a mean of 2.4 and a standard deviation of 0.58561, and the coefficient variable is 0.24782. This is the data collected about in regards to reaction times for adults with blood alcohol level of 0.8. The second histogram was created to portray someone who would be against drunk drivers. The data was meant to look like everyone who drinks gets totally impaired. And the third histogram was created to make people think that hardly anyone is impaired in this situation. It is safe to say to see how we can use the same data in all three charts, yet it can be represented in completely different ways to trick people according to whoever is presenting the data. And yeah, based on whichever type of histogram you decide to use. So always know your data and know to pay attention to how it is listed. By the way, over here is our is my Z-scores and the percentiles and the rankings and everything else, and this helped me to get my information. So I've been using that for the past, I think ever since I started the class. Anyway, so here's my path, like I said, and that wraps up Module 3, Excel, statistically speaking. Thank you for tuning in, and thanks for letting me be one of your scholars, Miss Benzie. Have a great night.